All right, so this is going to be a video involving the concept behind quadratic expressions with complex factors. So essentially what we're going to be doing is taking quadratic expressions and factoring them, and the factors are actually complex themselves. It'll make more sense once we do a couple examples, and we have a bunch of them here. So here we go. Let's start with the first one. All right, so this first one is x squared plus 4. And in order to factor this, since you can kind of look at it and just kind of see that it's not exactly factorable, one of the easiest ways to do this is actually solving this out, like finding the roots, finding the solutions, and then using those solutions to make the factors that are equivalent to this expression right here. So that's what I'm going to do. I'm actually going to solve this. I'm going to set this equal to 0 and find the solutions when it's set equal to 0, and then use that to make our factored form. All right, so I'm going to subtract 4 to the other side. So you're going to get x squared is equal to negative 4. Okay, I'm going to square root both sides, and you're going to end up with plus or minus the square root of negative 4. And the square root of negative 4, if you pull the I out, it's going to be plus or minus the square root of 4, which is 2 times I. Okay, but that's not the answer because we want the factored form of this. So what we're going to do is we're going to use these solutions, this right here, this plus or minus 2i, to make the expression that's equivalent to this one that we started with right here, this x squared plus 4. All right, so what you need to do is just do x minus each of the solution. So it's going to be x minus 2i, so that's the positive 2i, and then x minus negative 2i, since it's plus or minus. And then of course you were going to want to simplify this, so we're going to do a plus plus, and this ends up being the final answer right here. I'm going to rewrite it really quick. So believe it or not, this is actually the answer to the factored form of that x squared plus 4. So what that means is this thing right here is equal to x squared plus 4. Now it's not exactly easy to see, so what I'm going to do is actually solve this out really quick so you can kind of see that it is actually equal. And to do that, I'm going to use the area model. So I'm going to fill out the grid really quick for this. Okay, you end up with something like this, and this and this are going to cancel. And you're going to end up with x squared minus 4i squared. Well, I squared is equal to negative 1, so you're really going to be left with x squared minus 4 times negative 1, which is obviously going to simplify this minus and this minus right here, and you're going to end up with x squared plus 4, which is what we have right here. So this actually checks out. What I have highlighted in blue right here is the answer for the factored form of that original equation, x squared plus 4. Okay, it is really important to understand that you can always just grid this out like I did right here using the area model and seeing that you did actually get the right answer. So you can always check your work on that. All right, so this one is 3x squared plus 27. So first thing I'm going to do, again, you have to set this equal to 0 because you're going to use those roots, those solutions, to write the factored form. So I'm going to set it equal to 0 and solve. First thing I'm going to do here, though, is actually factor out the 3. So it's going to be x squared plus 9 is equal to 0. Okay, now from here, I'm going to divide both sides by 3. So I'm going to divide this by 3 and divide this by 3. So that's going to cancel. And you're going to be left with x squared plus 9 is equal to 0. Okay, I'm going to solve it the same way I solved the last one. I'm going to subtract off that 9 on both sides, and you end up with something like this. And then if you square root both sides with the plus or minus, you end up with x is equal to plus or minus 3i. Okay, now just like before, you just need to make linear factors of this. So it's going to be x minus 3i and x plus 3i. So you end up with something like this. But the issue with this is that we're not taking into account this 3 right here because we divided it off right here. So this part right here is equal to this right here, but you do need that 3. So what we're going to do is multiply our answer right here by 3. So we're going to have x minus 3i and x plus 3i. Now, if you actually checked your work on this, you would notice that that's the answer as well. Just to kind of save time on this video, I'm not going to do it, but you should actually check on your own. You should actually check by making the area model for this and seeing if you actually do get that 3x squared plus 27. All right, so the next one is the same thing. We're going to find the solutions first. So I'm setting this equal to 0. Okay, and to solve this, I'm actually going to use quadratic formula. So it's going to be x is equal to negative 6, which is just going to be positive 6, plus or minus the square root of 36 minus 48. And then all of this is divided by 2a, which is just going to be 2 times 1. So you end up with something like that. This is going to be equal to 6 plus or minus the square root of negative 12 all over 2. So I'm going to pull the I out on that radical. So it's going to be 6 plus or minus the square root of 12. So it's going to be 6 plus or minus I times the square root of 12. And then this is all divided by 2. I'm going to simplify that radical, that square root of 12. You can actually take out root 4 on that. So you end up with root 4, which is 2 times root 3. And then that all gets divided by 2. I'm going to divide the top and the bottom by 2, and you end up with 3 plus or minus root 3 I. Okay, so there's the 2 solutions for that, but we want to write this in factored form. So what I'm going to do is write x minus the plus version of this solution, and then x minus the minus solution of this. Now technically, because I was subtracting off the roots, it doesn't actually really matter if you do this or not because it ends up being the same, but you could put parentheses here. Now when you distribute though, it's going to be minus 3 and then plus root 3i, which is the plus was over here, and then minus 3 and then negative root 3i, which is minus over here. But just to be a little bit more exact, you can add that in there. But either way, you end up with the same final answer here of x minus 3 minus root 3i times x minus 3 plus root 3i. Okay, so these are technically conjugates because everything's the same except for this part right here. But that ends up being the answer for this one. All right, this next one, 6x squared minus 2x plus 1. Again, we're going to do the same thing. We are going to find the solution. So setting that equal to 0. Use quadratic formula. So it's going to be 2 plus or minus the square root of 4 minus 4ac, which is going to be 24. Divide all this by 12. So if I simplify this, it's going to be 2 plus or minus the square root of negative 20 all over 12. Okay, before I do any simplification, I am going to pull the I out of that square root of 20. So it's going to be I times the square root of 20, which is going to be 2 root 5 if you broke it down with the radical. Divide that by 12 still. We're going to divide the top and the bottom by 2. So it's going to be 1 plus or minus root 5i all over 6. Now that is not the final answer because that's just the solutions. You're going to use this to find the factored form of this. So it's going to be x minus this 1 plus, I'm going to do the plus version first, over 6. I'll put brackets on this one. And then times x minus the subtracted version of this, times 6. And then you end up with something like that, which is the final answer. And if you wanted to distribute, you could. It kind of is the same answer either way, so it doesn't really matter. But that ends up being the answer. And one thing I really want you to see is that you're using both of these solutions right here. Okay, you're using the plus and you're using the minus. Okay, to get that factored form for the answer. All right, the next one is a little bit different type of problem. And this one, it's just create a quadratic equation that has the solution 3 plus 2i. So this was discussed in a previous video, but all complex solutions come in pairs. So for this first one, let's put an arrow right here for this one. The quadratic equation could be x minus 3 plus 2i, put that in parentheses, times x minus 3 minus 2i. So the big thing is to understand that this plus really is going to be a plus or minus because all complex solutions to quadratic equations come in pairs. So you really have to understand that. They're called complex pairs. Now from here, you'll notice that there's some simplification that we can do, but we are actually looking for the quadratic equation. So this isn't actually an equation right here. Let's just set this equal to 0 for now to make it an equation, but it has to be completely simplified, and that's the next thing that we're going to do here. So it's going to be x minus 3 minus 2i, and then this is going to be x minus 3 plus 2i is equal to 0. Now, if you notice, we have a conjugate here, okay? This is a minus, this is a plus, so everything else is the same, so technically it's a conjugate, and all we really need to do here is square the first part. So I'm going to square this first part here. This is the first part. You notice those are the same. And then I'm going to subtract off by the second part squared, which is the 2i. You can kind of see right here, 2i and 2i are the second part. All right, and if you don't remember the difference of two squares, a squared minus b squared is equal to the conjugate. So it's a plus b times a minus b. Okay, so in this case, the problem we're doing, a is equal to x minus 3 and b is equal to 2i. So that's how I got that formula right there. Sorry, it's 2i squared. I forgot to put the squared in there. All right, now from here, I'm gonna expand this out. So it's gonna be x squared minus 6x plus 9 minus 2 squared is 4, I squared is negative 1 equals 0. Okay, then this is gonna simplify further. This is a negative, so it becomes positive. So you end up with x squared minus 6x plus 13 is equal to 0, and that's your final answer for that one. Okay. If you put this 3 plus 2i into that equation, you would end up with 0. So it does work out. All right, we're going to do the same thing for the next one where it's 1 minus I. It's just more practice of the same kind of concept. So let's put a line right here. Okay, so again, using the fact that complex solutions come in pairs, we're going to say that it's going to be x minus 1 minus I times x minus 1 plus I. Okay. So if you look at this part right here and this part right here, these are complex pairs. The only thing that's different with them is one's a minus and one's a plus. This is going to be equal to 0 to make the equation, but we need to simplify this completely. So we're going to end up with x minus 1 plus I times x minus 1 minus I is equal to 0. We're going to use that difference of two squares formula again to get x minus 1 quantity squared minus I squared is equal to 0. Okay, so we're going to end up with x squared minus 2x plus 1 when we expand this out right here. So these two things that I'm highlighting right here are equal. Minus negative 1 because I squared is equal to negative 1, and this is all equal to 0. Okay. This becomes a plus, this becomes a plus, and you end up with x squared minus 2x plus 1 is plus 2 is equal to 0 for your final answer. Okay, so that's a bunch of examples involving quadratic expressions with complex factors. If you have any questions about anything in this video, let me know.